interactive, keep it interesting. So I'll try and put some pauses in here throughout the conversation. And if you want to ask a question, just feel free. And if anyone puts a question in the chat, maybe Kaya can have you read those out if I pause to go through things. So like you said, this will be much more interesting if we keep an open conversation about it. So where do we start? If we just look at cellular technology, it's typically been rolled out, really looking over the last 40, 50 years, we see a new generation about every 10 years. It's been pretty consistent following this pattern. And we started off with mobile phones that were giant. They were briefcases of battery, and they really weren't good for much besides making phone calls. But what we've seen is that each generation since then has had kind of a defining use case that's really helped to get the technology adopted and pushed into the mainstream. And so what we've seen with 2G is we took it beyond that initial ability to make mobile calls and implemented SMS. So text messages really revolutionized 2G and what cell phones could do. 3G in the early 2000s is really where we started to get the idea of the smartphone, and we started to see cellular technology take off in a whole new way. This is where you could maybe check your email. There was very basic maps and new technology. But 4G has kind of exploded and given a huge push to new data. The applications that are listed here would be streaming video and voice over IP, but you could argue that on top of that, it's really this proliferation of apps that run on top of the cellular network. We have things like Uber that are taking advantage of the high-speed data connection combined with having a device that has GPS in it as well. Just really all kinds of new applications that if you were to ask about it 10 years ago, nobody ever would have thought. And so we're seeing the same thing with 5G. We're pretty early into the game of the actual commercial rollout, and the applications listed here, 4K, 8K video. To me, that's not terribly exciting. It's cool that we can do it over cellular, but it's a bit overkill, especially if you're watching a 4K video on something this size. How much can your eyes really take in? But you start getting into more interesting applications like doing augmented reality and looking into how artificial intelligence could be added into our network. And then 5G technology gets a lot more interesting. But the other thing that I think is important to notice here is all the lines, we have hard lines drawn on this slide, but everything's a little bit blurry. And so there's always things that are intended in the previous version that get rolled over into the next. And so some of the things that you'll start to see when we start talking about 6G are really holdovers and carryovers of what we just couldn't get done in 5G, or new things that we realized were possible because of 5G. And to be honest, that's why 7G out here, pretty much all question marks, because we'll see, in the next 20 years, there's a lot of potential for new development and where we can actually take cellular technology. So just a quick reminder about 5G and what it is, just to make sure we're all on the same page and do a little bit of a refresher. But the research for 5G really started, 12 years ago, 10 years ago. It's followed that typical pattern of, a 10 to 15 year rollout where the early research is done. The standards are then built based off of that early research, and then there's a commercial deployment with a ramp up period after that. Just even as recently as 2016, 2017, most people, at least here in Austin, still don't even have LTE. I remember being in a conference room and someone asking about that and just thinking, it's like, oh my gosh, my team is working on all this cutting edge 5G research and my phone didn't even have LTE on it. So, it's fun to get caught up in the excitement of the engineering of it all, but then there is a long deployment, especially in a country as large and as spread out as the US. We're lucky that we're here in a big city, so we'll get some of this stuff sooner, but really thinking about a full nationwide deployment takes some time. But 5G set out with there's a lot of common slides. If you've watched 5G presentations, there's spider diagrams, and then there's these triangles of looking at it, but there are really three different use cases that 5G wanted to tackle. The enhanced mobile broadband, which you can think of as better connectivity for your cellular handsets. Massive machine type communication, which is, adding tens to hundreds of times capacity, so doing IoT type applications, and then ultra reliable low latency, which I like to think of as anything where a human life is involved. You need that connection to be extremely reliable. You don't want your self-driving car's internet connection to drop when you go through a tunnel. That would be pretty devastating. So each of these areas targets a pretty different application space, but it also is made up of different technology inside of it, and allows some really different, interesting, and unique applications because of that. Now, as I mentioned, for 5G, though, we're in the midst of this deployment bubble. So where are we? If you look at 2 years ago, kind of when I was saying, even 2017, we're still working on getting LTE, but as early as, late 2019, there were about 40 vendors and there were 90 5G devices around. If we look now, we have iPhones. We're kind of a good, they're always a little bit of a good bellwether because Apple's typically a late adopter of this. They never want to have the first chipset that comes onto the market with the new technology. They typically wait for the second or third generation. So the fact that we have an iPhone with 5G is an indicator of where we are with this rollout of the technology itself. And in the next 5 years, we just expect that to proliferate. I would be very surprised if there's any phones out there that you're buying today that don't have 5G in some way, shape, or form. Maybe some of the lower budget ones, but for the most part, all the new phones are going to have this. As far as the operators themselves, we're up to 133 countries. It's probably more than that. This slide was made at the end of last year, so I think it was end of last year. And we're continuing to go and get more. There's still spectrum auctions happening, and more is getting pushed out. And the goal is to have 20% of the global connections be 5G by 2025. Today, we're about 400 million people, and that's globally. So there are countries where there's really high levels of 5G deployment, like Japan, like Korea, those nice small islands that are really easy to deploy and kind of hit your full target user base. But here in the US, there's a couple big cities that have it, but as far as deploying outside of a handful of those larger urban areas, the suburban is still very much lagging and will be a lot further along in that deployment rollout. And so, as I mentioned with 5G, we have kind of all of these different use cases that we're trying to tackle, and it can't all get done at once. So every version of cellular technology before, it's never been done in one version, one release of a standard. So the 3GPP, I'm gonna not say what the acronym is right, but they're one of the they're kind of the global standardization body that meets and sets the standards for cellular technology. They're the ones that did LTE and some of the previous generations before that. Oops, sorry about that. And so they're like release 8 was kind of the first one with LTE, but LTE is still advancing. It really got stable around at least release 11. So it took 3 iterations of the standard before it became kind of mature and finalized isn't the right word for it, but to a point where it was broadly available and more or less meeting some of the promises that it said it was going to meet. And 5G is no different. So what we think about with 5G, and when we started seeing commercials from folks like AT&T and T-Mobile, when they're talking about the 5G that they offer, okay, this must be on a timer, sorry. So when they're talking about the 5G that they offer, it's this release 15 version, and release 15 is really laying the foundations for 5G. It's coming in and saying the new frame structure and packet structure that's defined in the physical layer, and kind of looking at kind of the upper layer protocol stacks, getting into things, looking at adding in technology like massive MIMO, doing a first pass at some of the standards using new frequency ranges, specifically millimeter wave. It's version 1.0. And the 3GPP, when they set out, to their credit, they said they wanted to tackle all of these use cases. They didn't want to split up into multiple different standards bodies to try and hit different industries. 3GPP wanted to own all of it. And so that put a lot into one version of the standard. And so that's where we're going to see there's There's actually a lot that was packed into release 15, but there's a lot more work to do. So 15 was kind of that first version. 16 is really where we live now. It's more or less frozen, but there were some delays due to COVID, and so there was a little bit more time to work on release 16 than was initially planned. And now we're getting into release 17 as well. But release 16 itself is focused on kind of two main things. It's focused on looking at making efficiency gains, so looking at capacity and operational, and then it's looking at expanding into the new verticals, because the first version, it really was set on looking at kind of taking what we have with LTE in the traditional sense of using it with your mobile handset and making that better. But that's not what 5G is about. 5G is really about a lot more than that. So these are just some of the things that release 16 is looking to tackle. And, you know, as I said, the first version was for your phone. And so we had that come out in the early 2000s. And then we started to get, you know, tablets and smartphones. And by 2015, more things were starting to get internet, like your Kindle probably had it. Now we're looking at things like your Fitbit has it. Maybe if you have a medical device, it might have an internet connection as well to feed back information to your health provider. Things like refrigerators will even have internet connectivity now. So we're really starting to see this proliferation of things being connected. And it's not just for consumer devices as well. It's really looking at machines and how adding cellular connectivity to machines can revolutionize the way that they function. So we're starting to see things like driverless cars, and you know, Tesla's a good example of this. They don't have a 5G connection in them today. They're still using 4G, but even with that 4G connection, they're still able to do a lot. And they're just, you know, they're pushing software updates. And I don't think the Teslas are quite communicating with each other yet, but that's certainly something that I see happening in the future. And another key area that's a big one here would be for factories. So we're starting to see the machines inside of all of the different factories have an internet connection so that they can talk to each other, and then they can also talk back to operators and share diagnostic information. And that plays into also these new verticals. And specifically, keeping on that tone of the factory, the idea of augmented reality. I think it's a shame that this picture has a tablet, because I think it's going to be a lot more than that. It's going to be kind of integrated into a bit more of something we'd use in our daily life. Like, I don't know if you were following the news, but Facebook and Ray-Ban actually announced a collaboration to do smart glasses, kind of taking the concept of the Google Glass and making it less awkward and wonky to use. But they're trying to leverage this idea of augmented reality. And you can imagine an application that would be really useful for someone that's going and working on a manufacturing floor. They could look and see diagnostic information like this. They could see what's the health of the instrumentation, what's the throughput, is there a failure? If there is a failure, maybe it can pull up you know, a user guide for the piece of equipment that's failed, and just having all of this kind of information right at our fingertips. And another area you could really see this is even in someone like Amazon in a fulfillment center. If a technician can wear glasses and have information about what they're supposed to be picking right in front of them, you could see some gains and efficiencies there. And that's on top of just also adding, you know, some of the cyber physical systems. And kind of the last one that I didn't touch on that's really being looked at in release 16 that, at least on this side, is the idea of tactile internet. So to have tactile internet, that's meaning that there's, you know, a response that you're feeling. And the way that, or the key technical piece that's missing from that today is the latency. You know, if you're wearing VR goggles and you twist your head like that, if the motion doesn't follow within 1 millisecond of latency, you're going to get motion sick. That's the rate that your eyes are refreshing and capturing data, and like your ears and other parts of you. You need that kind of 1 millisecond loop for it to feel real and to not cause just a horrible kind of reaction from the human body. And so 5G aims to have that 1 millisecond latency. That's part of the ultra reliable low latency use case, to be able to enable things where people could remotely interact with machines to do applications like remote surgery. But as I mentioned, 5G builds. So we had this release 15 where it's focused on EMBB, the enhanced mobile broadband. So you focused on your cell phone. And then release 16 builds out on that foundational experience. So we get into all of these different use cases, which, we could spend 10 minutes on each one of these, if not more. But it's really meant to be there as a foundation for release 17. So with release 16, like you said, we're really starting to get deeper on a lot of those different applications by defining out more of the standard, looking at how we can make some of these efficiencies and kind of lay that next level foundation to take it even further and meet some of those initial goals that 5G had to set out. So I'm going to pause here for a second, so I'm not just talking at you incredibly quickly, and see if there's any questions. All right. So where does Wi-Fi fit into all of this, right? This is all about cellular, but let's be honest. Most of us, if we're sitting in our home, we're not using our cellular connection. We're going to use Wi-Fi. And at least in my case, my cell phone signal inside of my house isn't that great. And especially back when we were in office buildings, when they have, if you're in the middle of the building, you might be surrounded by concrete and have low-E glass and just really not great signal inside. So Wi-Fi really still does play an important role. And with that, we started off with 802.11b. We're able to build up and get more robust technology, get wider bandwidths, and working on getting more data throughput. But I think Wi-Fi feels a little bit threatened by 5G. So even if it's still kind of the incumbent technology, it's good to see cellular there to push the boundaries and kind of to make Wi-Fi better. So 5G does aim to increase the throughput and the bandwidth that you're getting on your cell phone to around 20 gigabits per second. And that's pushing Wi-Fi to kind of meet the same. And I know here, at least here in Austin, I think 1 gigabit Ethernet is getting pretty common. And Kai, you are off mute, by the way. You got some background noise.
We hired a contractor to do the concrete work.
There's someone's got some background.
During the installation of all our previous power places, both here and in New York, Susan and I had a hands-on involvement with the planning and
so we're looking at this data throughput, but Wi-Fi does still play an important role, and we're seeing
it easy to let someone else get the job done.
802.11ax is an important one as a first step, where it came out and kind of at a good time for during the pandemic, and we're looking to, and that's really the first Wi-Fi that was considered. And Wi-Fi 6E was even coming after that, with looking at 802.11 coming out in the future. Sorry, Kai, do you have the ability to mute?
Starts on the base. The contractors begin. That's the first.
Hi, are you there?
And he's digging.
It might be Glenn Jenkins.
Yeah, that's who.
Oh, sorry. Yeah.
Thank you. Thanks, guys. All right. So for Wi-Fi 6, this is really, I'd say Wi-Fi 6 makes a lot more sense for focusing on those 4K and 8K video applications, because typically, that's where we're going to be doing those things. We want to watch Netflix on our very large TVs at 4K and 8K. We want to be able to have someone in the house watching in 8K video and have me in another room still being able to do and present this. The bandwidth constraints that we're putting on Wi-Fi is a lot higher than in my opinion, is higher than we're going to be putting on cellular. And we also want to do cool things like play AR video games and VR video games with our friends. So there's a lot of really neat applications that are driving Wi-Fi to have that high speed. But that high reliability piece, especially in the last year, I think has become incredibly important. And I think we all feel this, that the boundaries of what was possible with Wi-Fi were really being pushed. And we really have come to think of it as a utility, and there's a lot of pressure within the industry to make that reliability as robust as possible, because this is something that we all depend on for our day-to-day job. And I know some of us are getting back to the office, but a lot of us aren't, and and we might not ever go back to the office. So this idea and this importance of having Wi-Fi reliability is incredibly huge. And so with the different standards, as you can see here, the AX with 6E is already looking at 10 gigabit per second. And so that's not quite all the way up to the 20 gigabit per second that 5G is looking to deploy, but I would say it's more attainable for a larger portion of the population today, at least getting to the 1 gigabit and getting somewhat competitive with what's available from cellular technology. And we're hoping within the next 2 years to get all the way up to 30 gigabit. We still have some work to do on the back end, certainly getting the providers to do that. There's a lot of work that needs to be done on the infrastructure side of looking at fiber and backhaul to be able to meet those needs. But as far as the standard is concerned and some of the end devices, there's really great progress that's being made in the Wi-Fi space. And one other area that I would be remiss to skip over is the concept of unlicensed spectrum within the 5G standard. So within release 16, and there's even some in release 15 as well, there's this concept of NRU, which stands for New Radio Unlicensed. And New Radio is the 5G equivalent of LTE and 4G, just the name that they've chosen for it. The idea behind New Radio is saying that cellular communications can operate in frequency bands that are licensed for Wi-Fi. I think this has some really huge implications for our quality of service for Wi-Fi and how these two are going to interact, and just in using our phones in the future. Back kind of earlier, probably around the 2015 timeframe, maybe 2016, there was a lot of work being done around this concept of license assisted access, LAA, and implementing a feature called Listen Before Talk. And that was the idea that if a cellular carrier wanted to operate in one of these frequencies, they could kind of blast out and say like, hey, anyone operating here? Hey, Wi-Fi signal, are you there? If it doesn't hear anything, then it's going to start talking to the device. It's doing listen before it broadcasts out. And so the NRU is really taking that kind of initial concept and saying, how can we get more spectrum for our cellular communications and play within the Wi-Fi community? I'm not sure if anyone has any idea or guess, but of how much spectrum, a license for spectrum in the sub 6 gigahertz range goes for. But if you're looking to get, a 20 megahertz chunk, or I don't know, being really ambitious and wanting to get 100 megahertz chunk, it's going to cost you billions with a B dollars to get a license for that. And it's a finite resource. So the spectrum is, for the most part, completely allocated. It's very difficult to get access to new spectrum. And so the cellular providers are sitting there thinking, it's like, well, Wi-Fi, it's not licensed, I don't have to pay for it, so why shouldn't I be taking advantage of that? There's nothing that says we can't. So they have put that into the standard of saying, how can we have these cellular communications happening in the same band as Wi-Fi, or just the general unlicensed spectrum. So notice it's not approved for the 2.4 gigahertz spectrum. There's a lot of other stuff that operates at 2.4. So it's pretty clustered, but they are looking at taking advantage of the 5 gigahertz band. And there's also a new band that got allocated for Wi-Fi and unlicensed communication, the 6 gigahertz to 7.125. So that's huge to have frequency or spectrum that's that low of a frequency that's available for this kind of communication. There's also a really big block of spectrum that was blocked off for Wi-Fi at 60 gigahertz. So going back here, it's this 802.11ad and 802.11ay. I don't know if any of you have a device with either of these technologies in it, but I know I don't. They were something that really looked promising, but never actually took off. I think it's an interesting concept for Wi-Fi because the electromagnetic properties of the waves at 60 gigahertz make it, you can either look at it as ideal for short communications or really prohibitive for doing more than probably a couple meters of communications. There's really high attenuation. There's high attenuation through water. It doesn't go through skin, but it's great for doing, short distance wireless. So there was a lot of work done to actually develop chipsets and the standard around 60 gigahertz for Wi-Fi, but it just never took off. And so now with the 5G and R, they're looking at, can they kind of take bits and pieces of that and make use of that spectrum that's already been allocated and set aside and use it for wireless communications. So release 16 is tackling some of the lower frequencies, and release 17 is going to be looking more at that millimeter wave frequency band. And there's a couple different ways that it can be implemented. I'm not sure how technical you guys want to get here, but there's an idea where you can either use an LTE tower and core, or you can use a new radio core or some combination of that to be able to implement this technology. So again, I'm going to pause. Any questions so far on 5G, on Wi-Fi, where we're going with all of this? All right, keep going. So I'd say that's kind of like one discussion of what's been happening in the wireless community. In parallel to that, there's been a big driver to move more of the processing into the cloud. And what I mean by processing is the processing that's happening in the wireless network. So not necessarily processing on the handset side, but really looking at the base station. So the idea of vRAN or virtualized RAN and CRAN, Cloud RAN, they're not new. They've been around for many years. But they're starting to get a lot of traction behind the idea of doing virtualization of the radio access network. Just kind of given a lot of different things that are happening in our current day and age. So I'd say the first one that's helping with this is improvements and advancements in COTS technology. Processors have gotten really cheap. So you can look at it of doing, GPU processors, FPGAs. There's a whole lot of different kind of hardware accelerators you can use, but just in general, processing has gotten cheap and pretty ubiquitous. So you can implement something on COTS hardware a lot cheaper and easier than you could have before. There's also a desire to disaggregate the RAN, and it's going to lead to being able to do optimization throughout the entire chain by having this disaggregation, or is the concept or the idea behind it. There's another idea. I don't know if the operators thought of this all on their own or if there's really more of that, but it's the idea of, quote, flattening the pyramid. And so typically you'd have a vendor that would make the components. Those components would go into a subsystem, and then you'd have your network equipment vendor building out that subsystem into what the operators eventually purchase. And it's pretty much a single stream. It's like a funnel like that into this pyramid where an operator will become vendor locked with their network equipment provider. And one network equipment provider has kind of got to supply the whole thing. And this idea was formulating before the trade controversies with China and the ban on Huawei, but that really helped kind of accelerate it. And there are a lot of political factors that kind of made ORAN the United States answer to how do we deal with Huawei. By being able to disaggregate the RAN, move everything into different vendors and allowing operators to mix and match, it allows for cross-pollination from outsiders or allowing new people to come and enter the market that might not have been there before. Add some innovation, but also add variety to the supply chain. Because if you're looking at the network equipment vendors, there's 4. There's more than that, but there's 4 that are consequential. There, you have Samsung, you have Ericsson, you have Nokia, and you have Huawei. And note, none of those are US based. So there's a lot of reasons why ORAN's appealing, because it can bring back some of that technology to the US, and it can also just open up for a lot of different innovation globally. And then the final area where that kind of cross-pollination and cross-domain innovation is really appealing and interesting with what's happening from our technological advances is starting to think about how artificial intelligence can be inserted into this entire thing. And what can we do with machine learning when we apply it to our wireless networks? So to try and tackle and answer all of these questions, there's a group that's called the Oran Alliance that emerged in the summer of 2018. So it was really 2 separate groups, XRAN and CRAN, that came together and said, and kind of came up with a charter and started to put together and act like a standardization body to make progress on this. So ORAN, if I had to summarize it, they have 2 goals. They want to have virtualized network elements with white box hardware and standard interfaces, and they have a focus on adding artificial intelligence into the networks. So we're starting to see this come for 5G, and we are already starting to see some of the first ORAN deployments happen, but it's also, in my view, this is foundational technology for what we're going to be doing with 6G, just based off of the desire to add artificial intelligence into the network. So, all right, so that's a lot of like really great high level goals, but what does it mean? I've made a picture here. I don't know everyone's background. I don't know how far into cellular you guys are, but if we look at a base station today, it would be running the part on the left of the screen. The green represents the different processing that goes in on a base station. So we have the RF, the radio frequency, and that would get handled by your RRH, your remote radio head. And that's pretty easy concepts to grasp. You have your analog to digital converters in there, your amplifiers, things like that. It's the analog hardware that's capturing or transmitting the RF signal. Then it gets sent back to a baseband unit, a BBU, over an interface called CPRI. And CPRI, I cannot remember what the acronym stands for, but it was meant to be an open interface between the 2, but it ended up really being proprietary. Every different network equipment provider really ended up implementing CPRI just a little bit different. And there's just enough kind of secret sauce that goes into the CPRI that makes it so you can't mix and match. There's a lot of timing constraints and timing parameters that happen here that make it so that only one vendor can manufacture this. Like you can't have the CPRI interface between an Ericsson BBU and a Nokia radio head would be different enough that they would never work together. And then the BBU is running, the different pieces of the protocol stack. So you have the lower physical layer that's kind of doing some of your FFTs, IFFTs, and some of the basic processing. And then you get into the MAC layer and then L3. And what ORAN's doing here is it's saying, well, let's split that up. Let's change the conversation and change what each piece of a base station actually looks like and where the processing is occurring. And by doing that, they also want to make open interfaces so that each of these can be a different vendor. So this F1 interface that goes between these 2 boxes here, that's something that 3GPP defined, but ORAN themselves have defined this one. They call it an ORAN front haul interface, or they allow eCPRI, which was a follow-on to CPRI, to be used, but it has to be open. And the other thing that you'll notice here is now this radio unit, an ORAN radio unit, it's not just doing the analog piece of it anymore. There's digital signal processing that's happening. And so ORAN has taken a look at kind of the signal chain. If you look at the starting, I guess if you're looking at right to left, it's the L1, L2, and L3, the layer 1, layer 2, layer 3. And they've tried to figure out kind of through the different levels of processing where they want to split what is happening with that radio unit and what's happening with the distributed units and the centralized units. And so they went with the split here between the hi-fi and the lo-fi, which is option 7. So if you ever hear someone talk about the 7-2 split in ORAN, that's where this comes from, is they're option 7, and then there's a couple different dot numbers that indicate how that split can be defined from a technical manner. So they picked .2. So all of this means now that you have a lot more processing on your radio unit, on kind of the highly time sensitive, some of the IFTs, as well as the analog part, and then a lot more of or all of the L2, some of the higher functionality and L3 on your OU, the DU and the CU. And in case I didn't give you enough acronyms, I put this slide in here to kind of remind us all what we're talking about and what does a network look like. So the whole idea of ORAN isn't to fundamentally change anything about what's going on in 5G. It's really just to look at the device, to look at the architecture of how a base station, or a 5G base station is called a G-Node B. So how a base station can be constructed, and to take some of that processing and allow it to be run on off-the-shelf servers and computational hardware instead of needing specialized hardware from a specific network vendor. And that's what's happening on this distributed unit and what's happening on the centralized unit. The other really interesting thing that's happening with ORAN is this idea of the RIC, the RAN Intelligent Controller. And so this is the part where AI is coming into play. So now they're looking at there's some non-real-time optimization that's happening, but they're also, or some real-time, they're also looking at how can AI be used to do non-real-time optimization? Like, what would happen if you could actually make tweaks to the performance of your network in real time based off of the real-world operating conditions? Like, if you know that you have really heavy user traffic at a certain time of day, can you allocate your resources to meet those demands? Or even looking at something like AI has already been used for doing things like network planning, of saying, if I'm in this regional area, based off of the waveform or the electromagnetic wave propagation and the surroundings, what's the best signal path? How do I want the antennas pointed? How do I want to run the MIMO from that RU based off of kind of this real-time performance indications of what's happening in the network? There's a lot of really cool stuff that's being investigated, and we're just at the tip of the iceberg of starting to explore how AI can be used inside of communications networks. So pretty cool things that's happening with ORAN. Things to remember are adding AI, disaggregating that network. And so a lot of acronyms here, but what I want to point out is, again, doing the old way, the concept of centralized RAN, virtualized RAN, distributed RAN, it's not new, but what ORAN is looking to do is to make it so that it's multi-vendor. They want to open up these interfaces. They want to do subsystem virtualization, open management of the orchestration. They want to have white box hardware so that hardware is more easily accessible, drives the price down, makes things like implementing a private network a lot easier, and then having open security to look at this entire thing. So now I do work for a test and measurement vendor, so I'd be remiss not to talk about the testing implications of all of this. It's really complex. I think that it's a tremendous opportunity for folks like myself to say, how do we go through and make it so that the testing is detailed, thorough, and sufficient to guarantee that a network is going to be able to stay up and running without adding so much expense that it's cost prohibitive to implement this kind of architecture. And just as an example to think about, if you're AT&T and you buy an ORAN G-Node B, and it's made up of things from 3 different vendors, the RU is pretty analog focused, so maybe there's not too many software updates. Maybe they're pushing a software update once every 3 months. But the DU and the CU are, they're COTS hardware and they're very, very heavily software based. So the DU vendor might be pushing out software updates once every month, and the CU vendor could be pushing them out once every 2 weeks. And they might not even be coordinated with each other. So you're getting a lot of different updates that are happening to the network that are being pushed out in real time. And so it becomes increasingly important to have the ability to, in real time, be able to test the network, make sure nothing breaks when these different software updates are pushed to the network. But then there's also the need to have the ability to troubleshoot very, very quickly if a problem does happen. You don't want to take down your entire network because you pushed a software update, but maybe you're not taking things down. Maybe just the performance is 5% worse. So what caused that 5% decrease? Where did that come from? And so that's another area where AI can be really interesting to see and use for doing some of that kind of continual testing, continual integration, and continual delivery. So there's a whole bunch of little nuggets there that we could have a whole other hour-long conversation about how this technology is evolving. But as far as testing, there's a lot to do, and it needs to be even more extensive than it ever was with 5G. And I'm going to pause again for questions. All right, so with that, so that's really, in summary, 45-minute summary of what's going on with 5G. There's a lot. It's continuing. It's going to continue for years to come. We're not done with 5G, even if you start hearing marketing people talk about 6G. 6G is exciting, but we're still in the very, very early stages. And just because there are some people that are start looking at 6G, that doesn't mean the work with 5G is stopping by any means. It's just maybe not as trendy or as exciting to talk about. But on the other hand, these cellular technologies, they're on this 10 to 15 year cycle where some of that early research really does start probably 5 years before you start seeing the standards come out. So if you look at it that way, we're right on schedule to talk about 6G. So I pulled this image and these concepts of a 6G vision from a group called HexaX. And they're a consortium of companies and universities and individuals based in the European Union who are working on an EU-funded project. But they've put together a really nice document. It's like 88 pages long if you want to dive deep. But they've started to think about and lay the groundwork for what should 6G be about? Like, how do we want to think about it compared to 5G? And they've kind of boiled it down to this idea of combining the digital world, the human world, and the physical world, and all of that to address our challenges of growth as a society, and how do we do all of this sustainably? So, very, very high level, those are the goals set forth by 6G. As with every other generation, beforehand, it's always kind of fun to predict, well, what are the hot use cases? What's going to make this grow? What are the applications that are driving 6G? And this is just a couple of them. As I mentioned, you see here, AI shows up. So we have AI looking at human-to-human interactions, human to machine and machine to machine. I think we're already starting to see that tip of just machine to machine interactions, but there's a lot more that we could do with AI. Doing more with kind of that idea of taking AR, augmented reality, and virtual reality, and adding in the idea of holographics. And once you get holographics, then the idea of, can we add in multisensory? So what would it be like if we could all be sitting here around a virtual table with our holographs on, but we could smell something, or have the ability to touch something? It's kind of adding those next levels of sense. Digital twins are another one that we're already kind of starting to see, but especially that concept that I talked about with Oran, where you have a lot of different pieces and a lot of different entities involved in creating an interconnected solution that don't necessarily have a good way of communicating with each other outside of a real deployment. So the concept of a digital twin is being brought in, and vehicle to everything communication is another area where you want to have a digital copy of the real thing as close to possible to kind of be doing all of your testing and real world analysis to troubleshoot either issues in the real world or to make sure that issues don't arise in the first place. And there's also kind of a humanitarian aspect of it too, where there's sustainability development goals, and they want to create opportunities and improve the quality of life globally, not just for within rich countries. So, you know, 5G was built off a lot of different types of technology, and 6G is going to be that same way too. It's not just one thing that's going to solve this, and it's not just looking at the handset anymore. It's looking at, you know, much bigger than that. So the radios that we're using, anyone who's an RF engineer, that's, you know, that's probably one of the most secure jobs I can imagine right now, because there's so much expansion in this area, and there's so much growth of going from 6 gigahertz and then 5G going to 28 gigahertz up to the 50 gigahertz. But we're already looking at what can we do at 140 gigahertz? What can we do at 300 gigahertz? You know, how do we expand that even further? How do we push the bandwidths even further? How do we do the signal processing of those bandwidths in a power efficient way? There's a lot there. And the other thing, and another key aspect, is the need to get that latency down. So I mentioned kind of that you turn your head and your eyes take about 1 millisecond to adjust. That's fine for humans, but machines are a lot faster than that. And so if we're going to be doing some of these really cool new applications, we have to figure out how to get our latency better. Integrating different multiple radio access technology, taking the concept of non-terrestrial networks really to the next level, looking at scaling massive MIMO beyond 128 antennas, 256 antennas. Like, what does it look like with 2024 antennas? What does the digital backend of something like that look like? And all of this can't really happen with the physical layer that we have today. There's going to need to be some improvements, and that's like the idea of slicing comes in, automated infrastructure, and again, you're seeing AI to kind of help drive all of these different things. And then the final one that I think is going to be in every generation of wireless from now on is security. It's huge in 5G, and it's going to stay there. But just as a comparison, I think that this is a nice visualization of a spider diagram for 6G of what they're aiming to do. 5G is the gray, where we have a lot of goals, you know, around that connectivity. We have goals around latency and reliability, getting the throughput up to, you know, the 30 gigahertz, 20 gigahertz area. There's a lot of work being done on battery life, but 6G, you know, it's the next generation, so they want to take it even further. So there's goals set around a conservative, and then there's ambitious goals set there as well. So just kind of some technical pieces that need to come into play to meet the application demands of 6G. And then, so where are we with all this? You know, as I mentioned, we started seeing with 5G back in 2010, 2012 timeframe. So about 10 years ago, we started seeing some of this early research that's happening, and that's really still the case with 6G. We see little pieces, little ideas, things of technology that are starting to emerge that there's a question of, like, will it make it into 5G? But it's definitely going to be a big foundational part of 6G that's starting to come into picture now. And 5G is also going to continue evolving while all of this happens. So really, we're a long way away from having 6G. We're another 10 years probably from having those early implementations, but things are starting to happen now. And it's not just happening in Europe, it's not just happening in the US, it's happening worldwide. So this is by no means an extensive list of everything that's happening, but it's an attempt to try and look at some of the different policies that are happening. Like, for example, there's 9 different research projects funded by the European Union as part of this 2020 or the Horizon 2020 project. The US has announced government funding for it as well. But there's also a lot of kind of joint collaboration at a global level that's going to be necessary to make 6G successful. We've seen this with 5G, and 6G certainly holds true for that as well. And so the final thought that I'm going to leave you with here for 6G is just kind of looking at some of the research challenges. There's not going to be one piece of technology that solves this. There's not going to be one area of engineering that can tackle all of this. You don't have to have a doctorate in digital signal processing to make an impact in 6G. It's going to touch a lot of different things, but also this is something, if you're younger or you know of a younger engineer that's looking and trying to think like, what do I want to do with my degree? How do I want to get involved? I think these are some of the really cool areas to talk about. These are some of the things that we're starting to see build up and are going to be there really for a long time to come. So these are, in my view, what's shaping 6G. And finally, I have, I sent Kai these slides, so we can send these out afterwards if anyone's interested, but I have just some different resources here. You can see what Keysight's already doing. We're involved in a lot of projects already for 6G and trying to help enable that. And then just some other white papers that were good, articles that were good. As I mentioned, this HexaX document, it's long, but it's really detailed, and just I was really impressed with the thoughtfulness that the writers put into it in trying to define what 6G is. So if anyone's interested in that, there's some good reading. And with that, I'm going to open it up one more time for questions. And thanks for letting me come and present and talk about 5G with you guys.
Hey, Sarah, thank you very much for your great presentation. It would be good if I understand about half of that. But during, I mean, 5G is of course still being developed and deployed now as your slides and your talk show, right? Probably at least for the next 5, if not 10 years. And I seem to remember during its evolution and current deployment, there were some questions about like the health risks of 5G, right, with the high frequency. And now, of course, with 6G, that seems like it might even get worse. Can you comment on work or safety and protection or whatever is being done in that area?
Yeah, and you know, I don't think I have to tell anyone on this call, like 5G is not going to give you coronavirus, right? Like we're all good. There's some really just wild conspiracy theories that have gone around that. You know, for 5G, I think the first thing that I would say is a lot of the frequencies that are being used are not new to being used. You know, they've been used for many years for cellular technology. But the other thing too that I don't think many of us realize is even the millimeter wave band, it's been a really active band for communications. It's just not been commercial cellular communications. Like there's a lot of military activity there. There's the weather radar uses some of this. And so it's not like these frequency bands have just been inactive or silent for the last 50 plus years. Like humans have been exposed to some of these bands for a really long time. But the other thing to think about too, when you're looking at the different frequencies and the impact on human life and on health is the concept of ionizing frequencies. And so you can see in the skin depth of that the wavelengths are going to resonate. So you know, certain frequencies will vibrate and resonate within the body, and you're going to absorb some of that energy. And other ones, you know, because of like water, the attenuation, they'll maybe go, I don't know, less than a millimeter or like things like that. So those are other considerations. And those are considerations that people take into account when looking at even what's viable today. But I think you'll also remember too, and like when we're talking about sub-terahertz, there was a lot of conversation around, you know, the health and effect and safety around some of the TSA airport scanners, like, you know, the ones where you stand inside, you put your hands up and they do a body scan. Some of those frequencies are also the ones that are being talked about use for cellular communications. they're talking about doing some really cool things where they combined the concept of like of imaging with communications. And so you could say, okay, you're doing this imaging and maybe you're looking for, if you're someone with a severe allergy, you could have a device that would scan and say like there's peanuts. Not too far-fetched to think that that's something that could happen with like a 6G device. But those frequencies, have been pretty extensively covered. And, I'm not as involved on the health side, but these are studies and things that have actively been happening and are continuing to happen. And those are also just some of the really basic considerations that that are taken into account before, FCC or any other governing body would even license them for this kind of communication. So.
Okay, thank you.
Sarah?
Yes.
With the propagation limitations of the 60 gig, how would that be useful to cellular?
That's a good question. I mean, I question this one a lot myself personally. I think the use case that cellular is looking to address with 60 gig is going to be in indoor settings and in highly dense settings. So one application where it might make sense is that I've heard is an idea of like at an airport, you could have a 60 gig tower from above and have it be like an area where you could go for high-speed downloads. And so it wouldn't go very far. It would maybe go, let's call it 10-meter circle. But it's somewhere where you could go and stay and go and download all your email downloads and videos for the next flight and have it be very, very localized. Why it works better for 5G than for Wi-Fi? I can't tell you. I have these exact same questions as you do, but I think the amount of spectrum that's there that's available for cellular technologies is just too appealing and too interesting to companies that have to pay billions and billions of dollars to access spectrum for them to at least not investigate further and see what's possible and what kind of business cases out there.
Yeah, thanks.
I have a question about deployment. So as 5G is rolling out, do you think in most cases the vendors are just replacing existing 3G and 4G base stations with 5G equipment? And I guess what I'm wondering is if you have say a 4G connection on your phone right now, and you know where you have that connection, can you assume that when they upgrade to 5G that will stay the same, or are they going to pretty widespread new deployments, new base stations, new towers, new locations for 5G?
Yeah, that's a really great question, Alan. I think the answer is a little bit of both. And so there's a technological piece that I'll mention. There's this concept in 5G, there's a non-standalone deployment and there's a standalone deployment. And the non-standalone, it uses parts of a 5G base station, but it anchors back to a 4G core. And so with that, I would expect to see maybe that radio unit and baseband unit for the 5G on the same pole as you would for 4G. And it's going to connect back up to that same core and they're going to talk. Most of the deployments that we have today are non-standalone. There are very, very few that are full standalone 5G deployments. So I think to your point, there's going to be both. There's certainly a goal to get to the point where 5G deployments are standalone and they're only 5G. But I imagine that those are going to be more of the new towers that would be put up and expanding into new areas, or in really, really dense urban areas where they truly need more connectivity than they have today. Mm-hmm. I think that 5G in the standalone mode is also is kind of going to be popular for more of the new deployments. So the other thing to consider too for 5G is like what frequency it's running on, for whether or not you're going to have the same coverage. And for the frequency, there's even a bit of like what provider do you have and what bands do they have licensed to for what's going to be better coverage. The merger between Sprint and T-Mobile is actually really interesting because of the spectrum that it gives them access to. T-Mobile now has the most contiguous bandwidth in what they call the mid-band. So it's in the, it's not all the way up at the 5 gigahertz band, but it's in the middle of that sub 6 gigahertz spectrum. And that frequency, it can travel further than some of the higher frequencies, and you can get a better signal strength for the amount of power that you're pumping out than what some of the other vendors have access to. So if you look at a map for 5G for T-Mobile, it's going to look really different than what AT&T or Verizon can offer just because of the spectrum license that they have. And so then there's also going to be some play where, you know, T-Mobile is going to come in and they're going to put up new 5G towers or just 5G pieces of it and then leverage their existing infrastructure to take advantage of this new spectrum that they didn't have access to when they did their initial rollout. So it's certainly going to be leveraging some of the existing infrastructure, but it's also going to be new deployment. And then that also ties into this idea of ORAN. One of the goals of ORAN is to make the equipment itself cheaper. And so what we're seeing in there's a pretty good kind of, I don't know if case study is the right word for it, but there's a real world example in Japan where a company, Rakuten, has deployed ORAN based 5G, and they're able to do it. I think that the percentage of it is like 20%. I don't know if anyone else here is a Wall Street Journal subscriber, but sorry, I'm pulling this up in real time so I can get you the data. There was a really good insert last week that talked about this, and they talked, oh, there you go. So Rakuten Group estimates their savings of 40% for building out their network by doing a standalone implementation of 5G and by using ORAN-based G-Node Bs. So there's this pretty but Rakuten can do it because they don't have all of the old equipment, and because they're a new person coming into the market. So a lot of different things at play here. I think 5G will be really important though for like rural deployments, and if they can get a base station at 40% of the cost, it makes putting up new ones for maybe some of the underserved areas a little bit more achievable from a business case. And it can also help to fill the void that our market, our American market is feeling by not having access to Huawei base stations anymore, because Huawei's prices were pretty unbelievably cheap for doing 4G. And a lot of rural providers were counting on having access to that cheaper technology to roll out high-speed cellular to rural areas.
Thank you.
So if we go to the millimeter wave 5G, do we need a different type of antenna? I mean, because the high frequency, then the range will be shorter.
Yes.
So we need more substation.
Yes. Yeah, definitely. so that's the first thing. Millimeter wave, you know, it's gonna. I really struggle to see it being successful outside of urban areas. It does need to be a lot shorter. The idea of a small cell, so you know, a lot more base stations, or even microcell and picocell. Yeah, it's going to be necessary. But what they are doing is they're using antenna arrays. So you have, instead of just having one antenna, two antennas, even four antennas, you're now looking at having, I guess on the handset they're putting like 8, but on the base station they might put 256. On like a CPE module that would be used for fixed wireless outward access, like 64 is a pretty common number. So they're putting all of those antennas so that they can do beam steering and beam forming. And instead of just radiating out everywhere and spending a bunch of power kind of doing a broad transmission, you're getting these like fine pencil width beams. I think like 3-degree beam width is pretty common. So all the power can be focused on where it actually needs to go instead of radiating to a general population. So that helps as well to extend the range of millimeter wave a little bit.
So I think Elon Musk tried to put up a few thousand satellites.
Yes.
For the purpose to improve the Wi-Fi coverage in the rural area, right?
Yes.
So there'll be a mix with the cellular network and the satellite communication.
Yeah. So that's an example of, well, his are satellite, but so he is doing satellite to ground.
Okay.
It's actually pretty cool what he's doing. you know, to be able to communicate like that. And I think his secret sauce is in being able to get the latency down. I don't know if anyone's ever had to use satellite internet before, but the latencies are pretty terrible.
Okay.
And you could also lose your internet when it rains. But you know, who wants internet when it's raining, right? So he's got some cool technology happening. Skylink, yeah, in that technology. But then there's also the idea to, so yeah, that would be to provide your Wi-Fi. But then there's looking at taking it. So he's launching full satellites into orbit. But you could also have something called a non-terrestrial network, which is maybe kind of the high part of the orbit to more or less deliver the same thing, but at a fraction of the cost. And companies like Google and Facebook are interested in doing this, as well as like for emergency responders, where you could have, like Google actually did a project that Google Loon, they put up these helium balloons right now, and they're doing more of like the drone airplanes that could be solar powered. So between the different, you know, layers of the atmosphere, there's a lot going on. But yeah, Starlink's pretty cool. My family has a summer house in Vermont and we don't have internet access. We're on the waiting list for Starlink. So ask me in a year, maybe I'll let you know how it works. It's supposed to be pretty great.
So would there be a merge between the satellite communication and the cellular network communication?
Yeah, I would say that's going to fall in, it kind of gets lumped into this non-terrestrial network is what it's called. And it did actually, there's part of it in the release 16 standard, and there's part of it that didn't get covered and is moving into release 17. And it's actually looking at like how can cellular base stations communicate with satellites and what pieces of, you know, the protocol would need to be modified. How do you account for things like Doppler in the physical layer and in the upper layers? So there's a whole area of research that's going on there. I don't spend as much time focused on that, so I don't have a lot of the details of the updates of how it's going, but it is a study item and work item for 3GPP that's being investigated.
So I think we have gone through the spec from 15 different versions to 17 to 18 using R6. I mean, the 6G will be less than revision than this in the 5G.
Definitely not.
So to get 18 times to really make it perfect.
Yeah. Well, I mean, they kept the same numbers, right? From, I don't know when it started. I know, like I said, LTE was release 8. And then release 15 was first version with 5G. So we'll see how many releases we can get in before 6G starts. We've got a couple more.
One other question about 5G that I was wondering about is, you know, you mentioned urban density and earlier you were talking about work from home. You know, there's been a shift, which is probably somewhat permanent, of people away from big cities. Mm-hmm. And, you know, I wonder how much of this has interrupted the plans of people that, you know, may have bid billions of dollars for auction space in the city where, you know, getting capacity for the network was the big problem. They needed to get as much capacity as possible. And I would think, maybe if you were to look at projections now for what's needed, that some of that capacity has shifted to the suburbs or even to rural areas. I wonder, this is not a field that I follow much, and I wonder if there's been any discussion about how that, you know, maybe you know, throwing the advantage to people that maybe were focusing more on suburbs and rural, the rural area, you know, rather than denser city centers.
Yeah. So as far as like cellular auctions and spectrum, I would say I don't see that changing. The urban areas, even if a lot of people move away, there's still going to be a demand. You're still going to have things like a soccer game where, you know, there's thousands of people gathered in a stadium and they're going to need that demand. Even if it's short, you're going to have that, and you're not going to have that in rural areas. So those use cases are still really well handled by cellular. You know, things with big airport hubs, those aren't going away. So for cellular, I would say it doesn't change the plan too much. but it's absolutely changed things for Wi-Fi. And one of the really exciting things that happened because of the pandemic, you know, there are certainly silver linings, and in getting high-speed broadband in rural areas is one of the areas that's benefited tremendously. So as I mentioned, I spent a lot of time in Vermont. I've spent a lot of time in a very rural part of Vermont. I have a 3 megabit DSL connection to my to my house when I'm up there, but there's a big push to get fiber rolled out. And so what the community there has seen, and what we've seen kind of nationwide, is a lot of money was allocated through COVID, and some of the financial relief packages was earmarked specifically for delivering broadband to rural areas. And so these programs that were slated to be done by, I don't know, 2025, 2030, and having money coming later, it all got sped up, and that money actually got pushed through a lot faster than anticipated. And so for the little community where I am, our county, we actually just found out today we got a $4.1 million grant that was just money that was there because of COVID that wasn't previously. And it's really helped to accelerate to now where we think we're going to get the whole community that's underserved fiber internet connection by 2023. So it's and you know, Vermont's 1 out of 50, but we're seeing a lot of similar things in other areas where that money got freed up and it's really accelerated and pushed. And you're starting to see it in Congress too. And if you listen to some of the political talks, one of the most highly aligned bipartisan issues is rural broadband and bringing high-speed internet to the masses and to the underserved communities. So we have that kind of momentum, and one of the only things that I think all of our politicians can agree on as a priority moving forward.
Yeah, I saw today that Burnett is being wired up with fiber now. Which, yeah, very welcome, I'm sure, to the people that live there.
Yeah, oh, for sure, it's a game changer.
So Alan, I don't think the majority, the people who are moving away, they are not in the rural area. They're in the second or third tier cities.
Yes.
And some are returning to big cities. So I think the second and third tier city, they get more tax revenue. They will improve the situation, education, communication, whatever, you know, that's composed of that population.
Well, it could be, Kai, but I could actually argue that. That's Alan's news is good news to me, because my weekend house is out in Burnett.
Oh,
okay. I can fully sympathize with Sarah in terms of ugly internet capability.
Yes, yes. Well, look at the other way. We expand the industry, the equipment will be cheaper, so will be more affordable by the smaller community.
Yeah,
the big ones.
Yeah.
But I thought the idea of a vacation house was to get away from the internet.
Good point. Good point.
Yeah.
I'm not retired yet, so I still have to be able to work from my vacation house.
Yeah.
it's more of a part-time retreat than, you know.
Right. Yeah. I think actually some tech people, they kind of move away for a couple of years and then moving back to San Francisco or some of the, you know, San Jose areas.
Yeah, it's done really weird things to the real estate market. I don't know if anyone's been trying to buy a house lately, but it's kind of crazy.
Yeah. I think Austin is crazy. Yeah.